Hi everyone, my name is Pradyumn and today we'll discuss the solutions to the first four problems from today's CF round, which was division 2. So we'll discuss A to D. Okay, so let's begin. Today's first problem it is called circle of apple trees. There are n apple trees arranged in a circle. Each tree bears exactly one apple, and the beauty of the apple on the ith tree is given by Bi for all I from 1 to n. You start in front of the tree 1. At each tree, you may choose to either eat the apple or skip it. After making your choice, you move to the next tree. From tree I, you move to tree I plus 1, and from tree n, you move to tree 1. This process continues indefinitely as you move through the trees in a cycle. However, you have a special condition. You may only eat an apple if its beauty is strictly greater than the beauty of the last apple you ate. For example, if B is 2, 1, 2, 3, and you eat the apple from tree 1, then you cannot eat the apples on trees 2 and 3 because they are not greater than the first tree, right? However, you can eat the apple 3 since b4 is greater than 3. b4 is greater than 2, right? Note that you are allowed to skip an apple when you first encounter it, and then you can choose to eat it later on a subsequent cycle. Your task is to determine the maximum number of apples that you can eat if you make optimal decisions on when to eat or skip each apple. Okay. So it's pretty simple. Like the problem actually says that we have n trees, right? And on each tree there's an apple. Okay. So let's say 1, 6, 5, 4, 2, 7, 3. Or let's add some duplicates also. 2, 3, 2, 6. Okay. And what you can do is you are moving along these trees like this. And from here you again move to the first tree. And you can choose to pick an apple if you have not picked it already, or you can ignore it. Like either you can ignore the apple, just go ahead, or you can if you are here, then you can choose the apple and then go ahead, right? So, and there's one more constraint, that whatever apples you choose, like you cannot choose an apple if the last one is not less than that. Like if you have chosen 6, then you cannot choose 6 or less than 6 again, right? So if I choose 1, I have to choose, like I can choose any of these. Like from 1, I go to 6. And I have an option that I can choose the 6 or not. Let's say I don't. Then I move to this 5. Now again, I have an option whether or not to choose this 5. Then let's say I don't choose it. So I am here at 2. So let's say I choose this 2. So I have chosen 1, I have chosen 2. Then let's say I move here. Okay, 2 is chosen. And let's say I move to 3. Then let's say I choose this 3. So 3 is chosen. Then let's say I move here, I don't choose. Then I don't. Then I choose this 5. Right. And basically, can you understand why I did not choose this 6 right here? Like, see, I chose this 3, right? Then I came here. I was not allowed to choose this 2 because this 2 is not greater than 3. Like the last thing I chose is 3, right? So I cannot choose this 2 now. So I move to 6. Now on this 6, I did not choose it. Why? Because on the next cycle, I want to choose this 5 also. So if I choose this 6 right now, I won't be able to choose this 5, right? So that's why I just skipped this 6 for now. And like I just skipped this 6 and I moved to the front again. Then I went ahead and I got this 5. So I chose this 5 and again I went ahead and I got to this 6, right? So in the end, I have 1, 2, 3, 5 and 6. So I have 5 apples. Like out of these 7 apples that were there, I have chosen 5 apples, right? And 5 is the answer. So essentially, there are some observations in this. Like from this entire process that I showed you, you can observe that the apples that we choose are definitely going to be in increasing order, right? Because for every apple, it is greater than the last one that you chose. So they are going to be in increasing order, right? And also, they are going to be unique. Like, of course, increasing order means that they are going to be unique. There can be no duplicates, right? Like you cannot have 1, 2, 2, 3. This 2 cannot come twice, right? So you cannot choose two apples which have the same value, right? So basically, if you have an array which has duplicates, like let's say we have this test case 5 4 2 1 2 3, 5 4 2 1 2 3, right? So yeah, so in this case there is 2 coming twice, right? So definitely we cannot choose both of these 2's. We can only choose one of these 2's, right? And for every number we can only choose one of them. So basically we have an upper bound on the answer, that our answer cannot be more than, that is, it is less than or equal to the number of unique values in the array, because we can only choose each unique value at most once, right? Now the question is that, is it possible to choose every unique value in the array? Like, is it possible? So in, like, using the given process that we can do, that when you are somewhere, just move to I plus 1, then I plus, like, then again I plus 1, like that. So while moving in a cycle, is it possible to choose all of the unique elements? And the constraint is that you have to choose them in increasing order, right? So in these, considering these two constraints, is it actually possible to choose all the unique elements in the array? So yes, it is actually possible. I mean, it is pretty simple to think about. Like, let's say you have this test case 1 4 5 1 2, 1 4 5 1 2. So the unique elements here are what? 1 2 4 and 5. So finally this should be your order that you have picked. So on the first cycle you will only choose one, okay? Then on second cycle, when you are iterating, you will only choose 2. Then on the third cycle you will only choose 4, and on the fourth cycle you will only choose 5. So this is how you can pick up all the unique elements. And since that is the maximum possible that you can do, like we proved here, that the answer is always less than or equal to the number of unique values in the array. So since the answer is definitely less than or equal to that value, and we showed a way to make it equal to that value, so that's why the maximum possible number of apples that we can pick is equal to this, the number of unique values in the array. So basically, in the input, whatever array you have been given, the answer is basically the number of unique values in the array. So there are many ways to implement this, like to print the number of unique values. You can use a hash map, right? And just print the number of keys in that hash map. Or you can sort the array and make the elements unique, right? There are multiple ways to do this. Or you can do it in n square also, because the n is given to be very small, right? So I have just sorted the array and printed the number of unique elements, as you can see in the code. Okay. Yeah, so in the code, I have int n, c in n, take the input of the array, then sort the array, and then print the number of unique elements in the array. So this unique function actually modifies the array and makes all the elements unique. Like, what it will do is, it will, let's say I have array 1 2 3 2 2 4 5 5. Let's say I have this array. Then when I apply the unique function to this array, then it will convert it into 1 2 3 2. These twice 2's will become only a single 2, 4 and 5. Okay, and this function will return the pointer to the next element after the last element. Okay, so that's what it returns. It returns the pointer to the next element after the last element in the new array, right? So if I just subtract the base address, like if I just subtract this pointer minus this pointer, I'll get the number of elements. That's what I did here, right? Unique of a comma a plus n minus a. So that's what the solution is. And all right, I hope you understood. Let's move to the next one. So the problem B was bitwise what is it? It's loading. Bitwise reversion. Okay. You are given three non-negative integers x, y, and z. Determine whether there exist three non-negative integers a, b, and c satisfying the following three conditions: a and b is equal to x, b and c is equal to y, and a and c equals to z, where and is the bitwise and operator. Okay, so the problem is pretty straightforward, that you have three integers x, y, and z. They have been given to you in the input, and you have to find out whether there exist three integers a, b, and c such that a and b should be equal to x, b and c should be equal to y, and c and a should be equal to z, right? So this is what the problem is. Okay, yeah, this is what the problem is, and we have to just find out that what is the answer, right? So how do we actually think about this? Let us think of a simpler problem. Okay, let's say we just have been given an x, okay, and we have to find out if there exist two numbers such that a and b equals to x. Like if I want the bitwise AND of a and b to be equal to x, then what is the condition? Let's think about that. Okay, so let's say x is some number 10110 or something, right? So if I want a and b to be x, like let's say this is a 5-digit number and b is also a 5-digit number. Like actually there are 32 digits, but 32 bits, right? But here I am considering only 5 bits. Okay, so let's say x is this 5-digit number 10110, then a and a and b are this. So if x has to be equal to a and b, then of course one thing is very clear, that wherever in x there is a 1, there has to be a 1 in a and b as well. Like in both a and b there has to be a 1, right? Because if there's a 0 in either a or b, then there will be a 0 in x also, if x is equal to a and b, right? So wherever there is a 1 in x, there has to be a 1 in a and b. Okay, and also wherever there is a 0 in x, there has to be a 0 in either a or b, or in both, right? Like there has to be a 0 in either a, like this, or in b, like this, or in both, right? That is the condition for a and b being equal to x, right? So let's think further now. Like this is the case where only one number was given to us, and we can observe these things, that wherever there is a 1 in x, there has to be 1 in a and b, and wherever there is a 0, there has to be a 0 in at least one of them, right? Okay, now we have the original problem. Like in the original problem we have three numbers x, y, and z, and we have to determine whether there is a ordered triplet, like whether there are three integers such that this a and b is equal to x, b and c is equal to y, and c and a is equal to z. So let's think about that. Now let us take a test case. Okay, let us take a sample and try to solve that. So let's say we have this sample 9, 10, and 12. This seems nice. So x is equal to 1001, which is 9. Then y is equal to 1010, and z is equal to 12, which is 1100. All right. Now if I want a and b to be equal to x, like let's just reconstruct a and b. Like let's construct a, b, and c. Of course there will be 4-digit numbers. If there is 4 bits in these, so there is no purpose of keeping more than 4 digits in either A or B or C, right? So they will be 4-digit numbers. Okay. Now, since in X, so X is equal to A and B, right? X is equal to A and B. In X, I have 1 and 1 right here. So of course, in A and B, I will have to have 1 right here. Okay. Then in like Y is what? Y is equal to B and C, right? And I have a 1 and 1 here in Y. So in both B and C, there will be a 1. So a 1 here and a 1 here. And in C also a 1 here and a 1 here. And similarly, we have Z is equal to A and C. So in both A and C, there will be a 1 at this position, right? So a 1 here, a 1 here, and also a 1 here and a 1 here, right? So I have these positions where there has to be a 1. Okay, that's cool. Now, so basically, all of the bits that should be 1 will be 1 now. Like, I have these A, B, and C. Like, these positions are fixed to be 1, right? Like, all of these bits which I have written, they have to be 1 for the condition to be satisfied, right? Like, I don't know about these 3 bits. Like, these 3 places, I don't know yet whether to fill 0 or 1 in them. But what I do know is there has to be a 1 in these cells, right? So what can we think about? Like, basically, currently, whatever I have the assignment, like with this assignment, I am guaranteed that wherever I want to have a 1, I will definitely have a 1 there. Like, irrespective of whatever I fill here, whatever I fill in these cells, it doesn't matter. But I will always have, like, if I compute A and B using these numbers, and if I compute B and C, and if I compute C and A, then it doesn't matter what I put here. I will definitely get a 1 wherever I want a 1. Like in this X, we have a 1 at the first and fourth position, right? So if I compute A and B, I will definitely have a 1 in the first and fourth positions. That's my point. That the ones have been made, they have been satisfied. Now all we need to ensure is that wherever there is 0, like wherever there are zeros, there should not be a 1, right? That is, by keeping a 1 here, like by keeping ones here, we have ensured that all of the ones will be made, right? But what we need to ensure now is that the zeros will also be made, right? Okay. So for that, like to ensure that, the best way would be to just insert zeros wherever we don't know, like wherever we can insert anything, we should just insert 0, right? Like my entire point is that in order to make these ones, I have been forced to put ones in these cells. Like I cannot put a 0 there, right? So it is forced. I have to put 1 there. But what about the remaining cells? So my point is that all of these ones have been made. Like irrespective of whatever I put in the remaining cells, these ones will definitely be made. Whenever I compute A and B, B and C, C and A, the ones which I require will definitely be there. But I also want to ensure that wherever I want 0, there should be a 0. And so I would just put 0 in the rest of them. So that, like, just to maximize the chances of getting a 0 in here. Like if I don't get, like let's say I put a 0 in the remaining spots and I still don't get a 0 on this. Like for example, in this test case, like 4, 8, 12. Let's say we have 4, 8, 12. So X is equal to 1, 0, 0 or 0, 1, 0, 0. Y is equal to 1, 0, 0, 0 and Z is equal to 1 1 0 0. So if I try A, B, and C. Okay. So basically, since x is equal to A and B, there's a 1 here. So I have to have 1 here. Then y is equal to B and C. So I have to have 1 here. And z is equal to A and C. So I have to have 1s here. Right. So I have to have 1s in these 6 positions. And the rest of them I just filled 0. Okay. But now the problem is, you can notice that when I compute A and B, like x has to be A and B, right? But when I compute this, what it comes out to be? It comes out to be 1 1 0 0. So as you can see, the one that I wanted, this one right here, has been made, right? But this 0 is not there. It has become 1. So even though I did my best to ensure that there would be 0 here, it is not made. Like 1 was made here. So like my entire point is, to maximize the probability of getting a 0 where you want a 0, just fill the remaining cells with zeros. And then finally check that whether or not you are able to get a 0 there or not. And if you are not able to get a 0 there, then it is not at all possible to get a 0 at all. Okay. So this is the entire logic. Like for every bit where there is a 1 in x, there has to be a 1 in A and B also. And the other positions, just put a 0, right? And then finally just check that is A and B equal to x, is B and C equal to y, and is C and A equal to z. And if it is, then print yes, otherwise it is not possible, so print no. Okay, so let me show the code now. Yeah, so I initialize A, B, and C as 0. Like initially all of them I put to 0. Then for the 30 bits, like from 0 to 29, if in x the ith bit is 1, then I set the ith bit to A and B to 1. And if in y it is 1, then I set to B and C to 1. And if in z it is 1, then I set to A and C. So I do it for all the bits. And finally, like, okay, of course, initially all of them had zeros. And I only filled ones where I needed ones. So the other will still have zeros, right? So basically I have filled zeros in the other spots. So even after doing that, if I get this condition that if A and B equal to x, B and C equal to y, and C and A equal to z, then I'll print yes, otherwise I'll print no. Okay. So this is the solution. I hope you understood this. Let's move on to the next problem. Symmetrical polygons. You are given n sticks where the ith stick has a length of ai. You want to choose a non-empty subset of these sticks and use them as the sides of a polygon. Each selected stick must be used entirely as a single side of the polygon. It is not allowed for 2 or more sticks to be joined end to end in parallel to form a longer side. Your goal is to form a polygon that is symmetrical, strictly convex, and non-degenerate. Okay. Among all such polygons you can form with the sticks, find the maximum possible perimeter. If no valid polygon exists, then output 0. Okay. Sorry. So what they are saying is that we have a polygon. Okay. Like we have been given an array. We have been given n sticks, right? N sticks. And the length of ith stick is a of I. And we want to choose some sticks and make a polygon out of it. Okay. So it's like, let's say I have the array 1, 2, 2, 3. Then I can choose this 2, 2, 3 and make a triangle like this, where this side length is 2, this is 2, and this is 3. Okay. So that's what I can do. Like this is one of the possible things. So I have to make a polygon by choosing some sticks out of the array. Like if this is my array and I choose these 3 sticks and I use them as a side of the polygon, right? But they have more constraints that this polygon has to be symmetrical also. Like basically symmetrical is it has to have a line of symmetry like this. Like I should be able to cut it from between such that both the sides are mirror images of each other. All right. So as you can see in this triangle, if I cut the triangle like this, then both the sides are mirror images of each other, right? Because I am cutting this in half. So this side is same as this side and this side is same as this side. So you can see they are mirror images. So we have to like choose some sticks from this array and make a polygon, right? Like any sided polygon, it works. Like not just 3, any sided polygon we have to make so that it is symmetric. Like there's a line of symmetry in that. Okay. And also we have to make sure that it is convex, right? Like we cannot make a polygon like this because this angle is not less than 180. Basically all the interior angles have to be less than 180. It has to be convex. All right. So that's what we have to do. We have to make a polygon and we have to like among all such polygons, we have to find the maximum possible perimeter of the polygon. All right. From those sticks. So how do we actually solve this? We have to just observe a few things about the polygons. Okay. Like what my point is, let's say we have a polygon which has some sides and which has a line of symmetry. Let's say I have this hexagon and just assume that this is the line of symmetry. Okay. So what does that mean? It means that if this side length is A, then this is also A. And if this side length is B, then this is also B. Okay. And also these two sides can be of any length, like C and D. They can be of any length. Like we can simply divide them in half. Right. So this is what your polygon would look like. That if you have a line of symmetry like this, then there would be two sides, C and D, and the other sides would be in pairs, A, B, B, right? Or it may be possible that you have something like this, that the line of symmetry cuts only one side. Like let's say you have a pentagon. Okay, and the line of symmetry is like this. Then in this case you have A, B, B, and C. That is, you have one different side and all the others are in pairs, right? Or what you can have is something like this, like the line of symmetry passes through no sides, like this. Like if this line of symmetry passes through no sides, that is, it is like this, A, B, B, and C, C. So basically you have these three cases, that the line of symmetry can pass either through two sides, or it can pass through one side, or it can pass through no sides at all. So all of the sides from which it is not passing, they have to be in a pair, right? Like all the sides, like this line of symmetry does not pass through these four sides, right? So they have to be in pair, like these two are a pair and these two are a pair, right? So essentially in your, like whatever you choose, like in your initial array you have A, which is some sticks. You have some sticks which is A1, A2, A3 up to AN, right? So my point is that whatever you choose, let's say you choose a subset of this, which is B. That is, you choose some sticks out of this to build your polygon. your symmetric polygon. Let's say you choose some sticks B1, B2, B3 up to Bm, and you want to make a polygon out of this. Then definitely I can say that these numbers have to be in pair, except for at most two numbers. Like what I can say is, let's say 1, 2, 3, 4, 4, 5, 5, 6, 6. So this is not allowed. Like this cannot be the array B, because there are three numbers which are not paired. Like these are paired, right? But there are three numbers which are unpaired, right? So I can definitely not make a symmetric polygon out of that. Like I definitely need to have at most two numbers which are unpaired. Like if you have something like let's say 1, 1, 1, 1, 2, 2, 3, 4, 4, and 5, 5. Let's say something like this. Then this only 3 is unpaired, right? So you can definitely just put this 3 somewhere. Like what you can simply do is you can make the line of symmetry pass through this 3. Basically this case right here, this second case. So you can make something like this. This is your one length side, another one length side, then two length side, two length side, then four length side, and then you have your five length side, right? So 1, 1, 2, 2, 3, 3, 4, sorry, not 3, 3, 4, 4, 5, 5, and here is your three length side. So since this 3 was the only unpaired thing, you made the line of symmetry pass through that side, right? And so this is possible, right? So basically you can have any array which has at most two unpaired elements, and you can make a polygon out of that. This statement is wrong. Okay, like my point was that B must have, like if you are choosing a subset B of this array A and you want to make a symmetric polygon out of that subset B, then of course B must have at most two unpaired elements. That is, if B has more than two unpaired elements, then of course we cannot make a regular symmetric polygon out of that, which is convex, right? But if it has less than two, like the reverse is not true. Basically, the reverse is not true. Like what I mean to say is that if B has less than or equal to two unpaired elements, then it is not always possible to make the polygon. Okay, and in which case it is not possible? Let me tell you. Okay, let's say you have an array B. Like actually in samples only they have given us when it is not possible. So we have 5, 5, and 10. Like just take this sample test case. Let's say I give you that my B subset is 5, 5, and 10. Okay. So as you can see, this B has only one unpaired element. Only one unpaired element, right? But still I cannot make a regular polygon, symmetric polygon out of this. Why? Because when I try to like make this as 5, 5, like I just did that, right? In the other example, what I did was I just put 1, 1 here, then 2, 2 like this, then 4, 4 like this, then 5, 5 like this, right? 1, 1, 2, 2, 4, 4, and 5, 5, and then I join them with a 3, right? But when I do this here, like I put 5, 5 right here, and then I join them like this with the 10. But the thing is that this 10 is too long. Okay. like you will be able to say it better if I make it 100. Okay, like just assume the array B was 5, 5 and 100. Okay, so I draw 5, 5, 5, and now I want to put 100 here, right? But of course this is not 100, right? This can't be 100. For it to be 100, these two sides have to spread so far. Like even if I spread them this far, they cannot become 100. Okay, that's the entire point. Like these lengths are too small to fit 100, basically. Like let's say if I do it like this, like we have 5 and a 5, then this may be 3 or something, right? But if I increase the angle between them, then this side length can increase. So this is 5, this is 5, maybe this is 8 now. But the thing is that the maximum that it can go, like, okay, first of all, I am not drawing it correctly. Like this length is 5, right? So if I increase the angle, this is kind of the thing. So now this may be 8. But whatever I increase, like even if I increase this entire thing to 180 degrees, then in that case, this would become 10 at max. Like not even 10, it can only become less than 10, right? The triangle inequality basically. Now the third side must be less than the sum of sum of two sides. So if I have 10 right here, like if I have 5, 5 and 10, then it is not possible. Like even if I spread them so much, then also making them 10 is not possible. So this was for three sides, right? But in general, if I have, let's say, if I have an array like 1, 1, 2, 2 and 8. So in this array also, there's only one element which is unpaired. So you might say that, okay, let's do 1 and 1 like this, 2 and 2 like this. And then I will put a 8 right here. But the thing is that this 8 is too long. Like this is not drawn to scale. This is not accurate. If like this 8 is too long to fit in here between these four sides. Like even if you increase the angle so much, like even if you make it 180 degrees, all of these. So in that case, it would approach what? Like let's say you make them a very big angle. Like this is 1, this is 1, this is 180 degrees. And again, this is 2, this is 2. And these two angles are also approximately 180 degrees. So in the end, this total length can become at most 6, right? 2 plus 1 plus 1 plus 2. So even if you spread them so long, it will still become only at most 6. So you cannot really have 8 side length right here, right? So if you have one unpaired element, like if B has an unpaired element, has exactly one. If B has exactly one unpaired element, then like let's say its value is K. Okay. Then that K has to be less than what? Like here we have 1, 1, 2, 2 and 8, right? And this 8 is too big because the sum is 6. Like the total that we can get is at most 6, right? 2 plus 1 plus 1 plus 2. So basically unpaired element K, then K has to be less than sum of the rest of elements. Sum of the rest of the elements. Sorry, that's the thing, right? If we have an unpaired element K in our array, then it has to be less than the sum of the rest of the elements. Otherwise, it is too long to fit in here. Okay. And so this was for one element case. Like if B has exactly one unpaired element, then what is the condition for which we can make the polygon? Like how do we determine can we make the polygon or not? let's say if B has no unpaired elements, like B has all the elements paired. Okay, then we can definitely make the polygon. Like there is no issue. Okay, like whatever your side lengths may be, A, B, B, C, C, then you can simply just make it arbitrarily, like A, B, and C. So A, B, and C like this, and similarly A, B, and C like this. And there is no issue. And essentially, why there is no issue? Because you just have to ensure that, like when you are putting these line segments A, B, and C, then you have to ensure that these 2 points lie on the same vertical line, right? And it is always possible. Like even if you have just 2 sides, A and B, and they are of any length, like just take any length, it is always possible to put them in such a way that the endpoints lie on the same vertical line. And in fact, whatever the way you put them, like you just have to ensure this angle is less than 180 degree, and just put them arbitrarily, and then just put the rest of the part in the same way, and there is no issues. So like whenever you have all the paired, like if you have all paired, then your polygon will always be possible. Okay, so if you have all paired, then always possible. Right, unless the side length is 2, like unless the B has only 2 elements, like this. Let's say if this is B, I have 2 sticks of length 2 and 2, so they are all paired, but of course it is not possible because I need at least 3 sides. Okay, so one unpaired element, the condition is this. Then if all are paired, then it is always possible. And let's say if 2 are unpaired, 2 are unpaired. Okay, let's say the side lengths are M and N. Okay, so let's take an example again. Let's say my B is 1, 1, 2, 2, 50 and 54. Okay, so of course this is the case where 2 are unpaired, right? So it will look like this. It will look like this thing right here, that we have one unpaired side here and one unpaired side here. They are on the opposite sides, and we have a symmetric line in between them, right? So that's what we will put it. We'll put it like that, that we have 50 here, we have 54 here, or okay, we have 50 here, then we'll put this side length 1, 1 and 1, then we'll put 2 and 2, and then we will put this 54, right? So now what is the condition? Like when can we do this? So following similar logic, you can simply identify that you can fit this 54 in here if this side length is less than the sum of all of these. Okay, so like 2 plus 1, 3 plus 50, 53 plus 3, 56. So if this side length is less than 56, then only you can fit this last thing into here. Otherwise you cannot. Like if it is greater than or equal to 56, then you cannot fit this new line segment between these 2 points. Like even if you spread out these angles to extreme far, like 180 degrees, then also you will get only less than 56, right? So that's why, that is the condition basically, that you have a side length A. Let's say like the 2 unpaired elements, let's say they are M and N, right? Where M is less than N. or less than equal to n. So what you need is that m plus the sum of the paired elements. Sum of paired elements. Basically this m 50 plus all of these paired elements, that should be greater than n, right? This 56 should be greater than 54. This is the condition. Or in other terms, I can say that this n minus m should be less than sum of paired elements, right? So this is what your condition is. So like if you have two unpaired elements n and m in your array B, then if this is satisfied, then your B array can be used to make a symmetric polygon. If you have no unpaired elements in your array B, then it is always possible to make a polygon unless the length of the array is 2. And if you have exactly one unpaired element, then also it is always possible. Sorry, it is not. The condition is that that element should be less than the sum of the rest of the elements, that is the paired elements. All right, that's what the point is. So now you have to simply, like, what was the problem? The problem was that you have to among all such polygons find the maximum possible perimeter. Okay, so basically you have to find the maximum possible perimeter. That means you have to choose a B, a subset B of this array A, such that its sum is maximized, right? Because the sum is the perimeter, right? Like these side lines are there of the polygon, so the perimeter is the sum of this elements, right? So you have to maximize the sum. Now the thing is that whatever you have, like, my point is that the paired elements do not cause a problem anytime. Like if you have a paired element, then you can always take it into the set. They never cause a problem. Why is that? Because first of all, this condition, just look at this condition. You want n minus m to be less than sum of the paired elements, right? So if I increase this, like if I include more pairs, then this sum increases, right? So the constraint becomes looser. Like I can have more possibilities for my n and m. So like my point is that including more pairs never causes a problem. Okay, that's my point. So whatever pairs there are in your array, in your original array, whatever pairs there are, like here in this array, we have two pairs, which is 3, 3 and 5, 5. You can always choose them and don't be afraid of anything. Okay. So let's say I just solve this test case. 1 3 3 5 5, sorry, 1 3 3 5 5 4. So this is the test case, the array A that we have been given, right? So out of this array, we can simply choose the pairs. Like just assume that we have taken these two threes, these two fives, right? We can definitely take these and there will be no problem. It will only increase our parameter. It will only increase our perimeter, right? So 3 3 5 5. This is our array B right now. Okay, and the remaining is what? The remaining elements that are there are 1 2 1 3 and 4, right? And the thing is that we can either choose none of them, like just keep this array as it is, and this is one possible answer, right? So one possible answer is 16. Okay, or we can choose any one of them. Like we can choose one of them, let's say k, such that the sum is less than, sorry, let's say we choose either 1 or 3 or 4. If we choose k, then the k has to be less than the sum of these elements. That is, k has to be less than 16, right? So we can choose either 1 or we can 3 or 4. Like we can choose any one of them, and it will be basically the single unpaired element. Like if I choose 3 here, or let's say I choose 4 here, then this 4 is the only unpaired element, and the condition for that was that it has to be less than the sum of the paired elements, right? So I can choose any element from here which is less than the sum. So I can choose this 4 and there is no issues, right? So of course, if I can choose any one of them, I'll choose the maximum one to maximize my perimeter. So this is also one of the possible answers. That is 3 plus 3, 6 plus 16 plus 4, 20. So currently we have an answer which is 20 also. So if we choose any one of the unpaired elements, then the answer is 20. But what if we try to choose two unpaired elements? Let's say, like basically if we are choosing m and n as our two unpaired elements where m is less than n, then our condition was that n minus m should be less than 16, right? Should be less than the sum of the remaining elements, right? So I have to choose any two elements such that their difference is less than this constant value, and also their sum is maximized, because I want to maximize the perimeter, right? And this sum is fixed. The paired wala sum is fixed, right? So you have to just maximize the sum of the two elements that we are choosing. So we have these two constraints, that n minus m should be less than 16 and n plus m should be maximized, right? So basically the adjacent elements difference should be less than 16. So how do you actually find such a pair? Like of course you can do it in O of n square, right? I mean, it is possible to do it in O of n square. Like just iterate over all the possible pairs, and for all pairs whose sum is less than 16, just take the maximum value of n plus m. That is one method, but that is in O of n square, right? So in O of n you can do it by just sorting this array. Like basically, let's say the remaining array, you have a1, a2, a3 up to ak, let's say. So this is the array which has all the unpaired elements right now, and you have to choose any two of them, n and like m and n, such that their difference n minus m should be less than a particular value, and their sum n plus m should be maximized, right? So how do you choose? How do you choose two such values? That is the entire boiled down problem right now. So for that, you can simply observe that in the sorted array, like let's say this array is sorted, okay, and you choose n as this one. Like if I tell you that your n is this one only, then what will you choose as m? What I'm asking you is, what will you choose as the m? If I tell you that the bigger element is this one, then what would you like m to be? So of course, if you want the difference to be smaller than k, and you also want the sum to be maximized, so of course both of these conditions suggest that we have to take the previous value. Like we have to ensure that m is as large as possible, because if m is large, then the difference will decrease, right? Because minus m. So if we take the m which is large, then it will also increase the chances of this being true, and also it will increase the sum. So of course, if we have this n, then we will choose the m which is as large as possible, but still less than that. So we'll choose this one. So that means if we have an n, we will definitely choose m as the previous one. So that means we'll always choose two adjacent elements from this sorted array. So we can simply iterate over all the adjacent elements. Like just iterate over the array. Like simply just check these two. That is their difference less than k. And if it is, then one possible answer would be their sum plus the paired elements, right? Then just continue, go on and check if these two elements ka difference is less than k or not. If it is, then they are one of the possible answers, and so on. And where this k is the sum of the remaining terms, right? And so on. You can just check for all the pairs, and out of these three cases, whatever the answer you get as the maximum, that would be your answer, right? Actually, in case 2, like in this last case only, you will get the answer. Like if you have any pair which is satisfying this condition, then definitely that is better. Like you will get the answer from that. Okay. But okay, you can just check all three cases and take the maximum of them. That also works. That's what I did actually. So yeah, and there's some edge case handling that if there are no pairs in the array, then the answer is 0. And if there's only a single pair in the array, then the case 1 is not possible. So there are some edge cases, yeah, that you have to handle, and I'll show them in the code only. Okay. So let's see the code. Yeah. So this is just for my reference. Like when I was thinking about the problem, I just wrote the things here. Yeah. So int n cnn, take the input, and I have this ans variable which is storing the sum. Like it is storing the sum of the paired elements. Okay. And I have this map right here which will help me pair the elements. So frequency array basically, right? Frequency map rather. Then I have this vector of a level v which will store the unpaired elements. Like this v vector will store the unpaired elements. And this count will store that how many sides, or yeah, how many sides have I chosen in a pair. Like basically number of pairs that I have chosen into 2. That is stored in this count. Okay. So I will iterate over the frequency array. If it is odd, like the frequency of the current element is odd, then it is unpaired, right? So I'll put it in the unpaired elements list, and x dot second divided by 2 ka floor, that is the number of pairs of this element. So I will add it to the sum. I will add number of pairs into 2 into that value, that will be added to the sum, and count will also get incremented by x dot second by 2 into 2, right? Basically x dot second minus x dot second mod 2. So at this point, if ans equals to 0, that means you found no pairs in the array, and that is not possible. So the answer is 0. Then you can sort the unpaired elements array. Then this is the first case. First case is like you can choose all the elements which are less than the sum of the paired elements. Like if you just choose one unpaired element, then you can choose the one which is less than the sum. So finance just stored the final answer. So if v of I is less than answer, then I can have, like if v of I is less than the sum of unpaired elements, one of my possible answers is sum of unpaired elements plus v of I. That is, I choose all the paired elements plus this one unpaired element, right? And then this is the second case, that if I choose two unpaired elements, that is v of I and v of I minus 1. So if v of I minus 1, it is less than ans, that is the sum of, if it is less than the sum of the unpaired elements, then we can do, like if it is satisfied, then it is one of the possible answers. So finance, like final answer is equal to max of final answer comma ans plus vi plus v of I minus 1, right? And finally we just print the answer. But also the case 1, like the case where we do not take any unpaired elements. So if count is greater than 2, that means if we have at least 4 edges, like if we have only 2 edges which are paired, then of course we have to take one more, right? We have to have at least one more unpaired edge. But if it is greater than that, then we can have all paired also, right? So this is what that case is, and finally just see out final answer, right? So this is what the problem C looked like. let's move on to the last problem of today, problem D. Okay, so it is loading, I guess. Let me try to turn this off. It is not loading for some reason. It's, yeah. This was the problem. It is called not alone. A circular array B of length m is nice if every element has at least one adjacent element that is equal to it. Formally, okay, formally को छोड़ते हैं. Like circular array is clear. Like basically the first and last element are also adjacent in an array. So every element should have at least one element adjacent to it, which is the same as it, right? You are given a circular array A of length n. In one operation, you can increase or decrease the element of A by 1. Your task is to determine the minimum number of operations required to make array A nice. More formally, find the minimum value of summation bi minus ai absolute value among all nice circular arrays B of length n. Okay. So this is a problem which says that what we have, like they have defined a nice array. Like for a circular array, they have defined that what is nice. Right. So what they are saying is a circular array B is nice if for every bi, either it should be equal to b of I plus 1 or it should be equal to b of I minus 1. Like either one of the two should be true. Either it is equal to b of I minus 1 or it is equal to b of I plus 1. Okay. And basically it is circular. So before b1 there is bn, right? And after bn there is b1. So it is circular array, right? So like for example, this 4 2 2 4, this array is also nice because before this 4 is right here. So adjacent to this 4 is this 4, which is the same to it, right? Whereas the array 1 2 3, this is not nice because beside this one there is no adjacent element which is equal to it. Okay, so we have to determine that, like in one operation we have been given an array A, right? And in one operation we can increase or decrease the elements of A by 1, any element of A, I mean. And we have to determine that what is the number of operations that we need to like make the array A nice array, the circular array a nice array. Okay, so let's look at the samples first of all. Like this 1 1 1 1 1, this is already nice, right? Because for every element it has an adjacent element next to it, right? Then 299 and 3. So in this, clearly what you will do is just increment this 99 and make them 100 100. So these two elements are fine, and then you can decrement this 3 and make it 2. So this 2 and 3, like I mean this 2 and 2, they will become side by side and they will become nice. Okay, then in this array you can simply decrement this 9 4 times, that is make it 2 2 5 5 5. So in this final array it will be nice, and In this array, you can increment this 1. So in one operation, you can make it a nice array, right? So actually, a nice array, like to solve this, just think about the nice array in terms of groups. Okay. First of all, let's forget about the circular thing. Okay. Like let's say in the problem, it was not circular array. Just ignore the circular part. Okay. Like just assume for now that it is linear array. Linear array. Okay. So basically, how would you define nice? Like they have defined nice array as every element should have at least one, should have at least one same adjacent element, right? So what they are saying is that in a nice array, every element has at least one adjacent element which is the same, right? So basically, your elements must be in groups. Like that's what I can say, right? Like if you just divide your array into groups and just forget about the circular thing for now, right? So let's say I have 1 2 1 1 3 3 4. Okay, so this array is not nice. Why? Because when I make the groups like 1 2 1 1 3 3 and 4, so these two groups are of size 1. Like my point is that in a nice array, all the groups have to be of size at least 2. Okay, like let's say I'll make an array which is nice. Okay, okay, so let's say this is the array. So if you see the groups, this is one group, this is one group, this is one group, and this is one group. So all of these groups, or let's say we have more ones right here. So this is one group, right? So all of these groups have size more than 1, right? In this case, these groups had size 1. So in a nice array, all the groups must have size more than 1. Okay, that is the thing. So that's how you can actually define nice in simpler terms, right? So this is for linear array. And what if it was circular array? Then the only difference that would make is that, let's say this is the thing. Let's say this is your array. Then you would have this one group, and this would also be one group. Okay, because the array is circular. So these two elements are adjacent. So you can make them in one group. So this is nice if you take a circular array, but in linear array it is not nice. Okay. So anyways, my entire point is that a nice array will definitely have groups of size more than 1. Like all of the groups that are there, they must have size more than 1. That means the array which is given to us, we have to convert it into a new array which has groups of size more than 1. And what does group mean? Like basically all the elements in the group will be the same. All elements in a group will be the same. Okay. And group size has to be more than 1, right? So now how do you actually proceed now from here? So the thing is that there is one observation that you have to make right here, which is pretty crucial. Okay. Like let's say I give you this array 22595. Okay. And I tell you that in the final array, in the final array, what do I want the groups to be? Like, let's say I tell you that I want one group to be like this and one group to be like this. Okay. Then is it not easy to tell me the answer? Like, is it not very easy to tell me the answer? Basically, what I am telling you is that in the final answer, I want one group to be like this and one group to be like this of size 3. So of course it is pretty easy to tell the answer, because you can simply say that these two are already same. They are already in the group, so it will take 0 cost to put them right here. And for these 3 elements, you want them to be same, right? You want these 3 elements to be the same. And what you can do is either a of I plus plus or a of I minus minus. So of course what you will do is you will take the elements to the median, right? Like, this is a very standard problem, right? That if you have some numbers and you make them, like if you want to make them all equal, and what you can do is either increment or decrement the element by 1, then you will bring all of them to the median, right? So you will bring all of these 3 elements to 5. So 5, 9, 5, you will bring all of them to the 5. So you will make them 5, 5, 5. And therefore, this 4 operation, like the 4 operations were used, right? So my point is that if you know that what are the final groups, then you can easily determine that what is the answer. Because for each group, you just have to make all of the elements equal to the median, right? Now one more thing is there. Okay. Like, let's say I have this 1, 1, 1, 2, 1, 2. Or let's say I have a bigger array. 1, 2, 3, 6, 5, 6, 5, or 6, 5, 6, 7. Okay. So let's say I have this final array of length 7. Now let's say I tell you that I want these groups, this 3 group size and this group of size 4. Like, basically in the final array, all the groups have to be of size at least 2, right? That is the condition. Like, if in my final array the groups have size, all of them have size at least 2, then of course that final array is valid. It is nice. So if I have this kind of configuration where I have this group of size 3 and this group of size 4, then of course it is valid, right? Because all of them have size at least 2. Okay. So if you try to make this array into group like this, then what will you do? Basically, in this first one, you will make all of these 3 elements into 2, because 2 is the median. So you will make them all 2. And these 4 elements, you will make them all the median. So what is the median? It is 6. So you will make them all 6, right? But my point is that making all of these 4 elements the same, that is very constraining, right? Like, my point is that I told you to make it like this, and if you are able to make it like this, it is valid answer, right? But what if you just make it like this? Like, instead of having this a big group of size 4, what if you make 2 small groups of size 2? Like, what if you make it like this? This is also valid, right? This is also valid. And this is actually more better, because now you don't have to ensure that these 2 groups have same numbers, right? Like, if you wanted to be like this, if you wanted this, then you would have ensured that all of these 4 numbers have to be the same. That is more constrained than this one, because in this one you just need that these 2 should be same and these 2 should be same. So of course you will never make a group of 4, because that will take more effort, right? Like, let's say I have 1, 2, 3, 99, 100, 3, 4. So if you try to make groups like this, these 3 group like this and 4 group like this, then making this 4 group would be very hard, because making all of these numbers equal is very hard, right? But if you just make the groups like of 2 size, like instead of this 4 group size, just make them of size 2 2, then it is very easy, right? So my entire point is that you will never make group of size more than 3. Like, my point is, you should never make groups of size greater than 3, because if you have a group of size which is greater than 3, you can always break them down into size 2 and 3. Like, you will always make groups of size 2 and 3, because if you have more than that, you can just break them down into 2 and 3, right? You can always break them down into 2 and 3, and breaking those groups down into size 2 and 3 will still satisfy the constraint, and it will decrease your answer, right? So in your final answer, like, your final answer will have will have groups of size 2 and 3 only, right? And finally, you just have to figure out that what is the optimal way to group this into 2 and 3 such that the answer is minimized. Like, let's say this is your array 1, 2, 3, 99, 100, and 3 and 4. So let's say you grouped it like this. If you group these two, and these 3, then this is a very stupid grouping, because this 3 and 99 you want to make them same, although they are very far apart. And this 100, 3 and 4 also you want to make them same, which will take too much cost. So this is a bad grouping, because it takes higher cost. Whereas if you group these 3 together, these 2 together, and these 2 together, then it is a very low cost. So you have to determine that among all such groupings, what is the optimal one, right? And currently I'm talking about linear one only, okay? Like, just ignore circular part. Like, in the problem, just assume that the array is linear. Just ignore the circular array thing, okay? So currently we're solving for linear. So for linear, you want to just group them into like groups of 2 and 3, okay? So basically you want to find the answer for some array, right? Like, let's say you have an array a1, a2 up to an, right? You want to find out the answer for this array, that what is the minimum cost to make them into groups if you can form groups of size 2 and 3. So simply what you can do is that, let's say you want to calculate the answer for a prefix, like let's say a1, a2 up to ai. You want to calculate the answer for this prefix, okay? Like, if this was your array, then what would be the answer? You want to calculate that, okay? Let's call it dpi. Then how do you calculate dpi? That is the question. So the thing is that this ai, like this element ai, it is the last element, right? So either this last group will be of size 2, right? Like ai minus 1 and ai, or it will be of size 3, that is ai minus 1, ai minus 2, and ai. I mean ai minus 2, ai minus 1, ai minus 1 and ai. So either this 3 length group or 2 length group will be there, right? So that's what you can observe. So in both the cases you can find out the answer. Like, if you have a 2 length group, That is, you want ai minus 1 and ai to be the same. Then what would be the cost to make these two same? It is basically absolute of their difference, right? A of I minus 1 minus A of I, right? And plus, you would have to, like, it just boils down into the sub problem. Like, the remaining portion you have A1, A2 up to A of I minus 2. So you can just use the answer for this that you already have. So this is basically dp of I minus 2 plus mod of ai minus 1 minus mod of ai minus 1 minus a of I. So like I am just breaking the entire problem down into a smaller subproblem. That, okay, let's give an example. All right, like let's say if I want to find the answer for 1, 2, 3, 1900, 3, 4. 1, 2, 3, 99, 100, 3, 4, right? And let's say I know the answers for all the prefixes. Like, okay, let's say I know that to make all of these equal, or to make this prefix nice, my cost that would take me is 3, right? The answer for this is 3. And the answer for this thing is what? I can only divide into 2 and 2, right? So the answer for this thing is basically 2 plus 96. So, sorry, 1 plus 96, 97. Okay. So the answer for this part is 3 and the answer for this part is 97, right? So let's say you want the answer for this entire array, right? So either the group would be like this, like the last element would be in a group of size 2 or a group of size 3, right? So if it is in a group of size 2, then it would take one operation to make these two equal and plus 3 to make this prefix nice, right? So 1 plus 3, which is 4. And if you assume that this would be the group, like the last element is in this group of size 3, then to match this group of size 3, you will take 1 plus, like basically 3 will become 4, so 1 operation, this will become 4, so 96 operations, and 4 will become 4, 0 operations, so 97 just to sort this group, and plus the answer for this prefix. Like you have this group right here and you also want to make this prefix nice, so 97. So the answer would be 194. So basically you would take the minimum of them. 4 and 194 mean the minimum is 4. So the minimum cost for this entire prefix would be 4, right? And that's how you can use dp to like solve this problem. All right. Now the thing is that what about circular part? Like we solved this problem for the linear part, right? Like if the array was linear. But what about circular thing? Like we are allowed to make groups like this as well, right? Like the difference is what? The difference in circular and linear is that in the linear thing, we were allowed to make groups only like this, right? But in circular thing, we can make groups like this also. Basically, this is one group, this is one group, and this is one group. Okay, this first group, second group, and third group. This is also allowed, right? But the given that, but like in this case also, of course, in circular case also, in circular case also, we will make groups of size only 2 and 3. 2 and 3 size only. Like we will never make groups of size more than that, right? Because we can always break them down into 2 and 3. So if I solve, like let's say in this problem, I just solve it using the linear algorithm. Then when can it give it a wrong answer? Like when can it give me a wrong answer? Let's say we have this case 100, 1, 2, and 99, right? So in this case, my linear algorithm will give me a wrong answer because it will form the groups like this, right? But actually, the optimal way is to form the group like this. So basically the linear one will give me wrong answer if there is a group which is like this, right? Like if there's a group which is uh, like this first group, then it will give me wrong answer, right? But what I can do is I can just cyclically shift this array. Like let's say I cyclically shift this array to the right by 1. So what will it become? It will become 99, 100, 1, 2. And now I can apply my linear algorithm. So in that case, it will give me this group and this group, right? So basically, I had the group like this, right? I had one group like this and other group like this. So this group was broken up. But when I shifted it cyclically, like this input array, when I shifted this cyclically, this group became one. Like this group, which was divided into two parts, became one part. And so my linear algorithm correctly gave me the answer. And since I have groups of only size 2 and 3, like if I have groups of size only 2 and 3, in the worst case also I can simply shift 2 times and get the answer. Like basically, let's say in my circular case, let's say the optimal way was to make this group 1, like this one element and these two elements like this. So a group of size 3 and a group of size 2. So let's say this was the optimal way to do it. Like let's say the input was something like 100, 99, 98 and 1, 2. So this would be the optimal way, right? But my linear algorithm would not give the correct answer using this. So what I will do is I will shift this once. So it will be 98, 9, 9800 and 1 and 2 and 99, right? But so my algorithm will still give me the wrong answer because it would probably divide it like this, right? So I will shift this once more. So if I shift this once more, it will be 99, 98, 100, 1 and 2. So at this point, my optimal groups do not get cut. Like I do not have this situation right here. Like basically when I shifted this, I eliminated the possibility of this situation. So now all of my groups are together only. And since I know that my group size is at most 2, like at most 3, so I won't have to shift more than 2 times. Because if I shift 3 times, it will again be the same. Like I think it is pretty obvious that any group which is of size 3, if I just shift the array 2 times and just check all 3 arrays, then either one of them will have no groups which are cut. Like what I mean to say is that if I have groups of size at most 3, like this, I have this 3 group, like 3 size group, which is being cut in between. So I have to shift this at most 2 times. If I shift this 2 times, then this group will eventually become a single entity. So what I can simply do is just take the input array, find the answer for that using linear, then shift it once. So this is the new array. Check the answer for this one also and shift it once more and check the answer for this one as well in the linear case. And definitely I'll get the optimal answer in using these 3 steps. And all of these 3 steps will take O of n time. So because my DP is O of n, so like O of 3 into n, which is basically O of n only. So I solved this problem in O of n, right? So this is your algorithm for this problem. Now let us look at the code now. Okay. Sorry. Yeah, so this is my function which takes in the array and finds the answer for that using linear algorithm. Okay. So I have some edge cases, like if n is 1, then return 0, of course, and if n is 2, then return their difference, right? And I insert 0 on the beginning, like I just insert a padding because I want the array to be 1 indexed, not 0 indexed. Okay, because my DP also is 1 indexed. Okay, and my DP of 0 is 0 because like this is basically empty array. The answer of empty array is 0. And DP of 2. DP of 2 means A1 and A2. So like the prefix which has A1 and A2. So the answer would be absolute value of V2 minus V1. So these are the base cases. And I start from I equals to 3 to n. So DP of I. DP of I means the answer for A1 to AI, right? So either I have a group of size 2. That means Vi and V of I minus 1 are in single group. So my cost would be absolute value of Vi minus V of I minus 1. That's what this dist function is doing. Plus the DP of I minus 2, right? This is one possibility for DPI. Or we can have the last 3 elements in a single group, right? So of course they will, like of course we will convert them to the median, but I just check all 3 of them. Like I just check all 3 possibilities. Like basically if I have a group of size 3, then all of these 3 numbers would be converted either to 99 or to 98 or to 100. That's what I observed. So I just checked all of 3. I just checked all of these 3 and I took the minimum. So this is a clever bit of code which checks all 3 possibilities, okay, and takes the minimum in this variable. So basically the cost of making all 3 elements equal is stored in mi. And finally, like one of my possible answers, like if I take the group of 3, the last 3 group, then the answer is dp of I minus 3 plus mi, and I will take the minimum with dp of I. Like either this is the answer, dp of I minus 2 plus absolute value of vi comma vi minus 1, or this is the answer, dp of I minus 3 plus mi. So I'll take the minimum of them, right? And finally just return dp dot back. Dp dot back means dp of n, right? So this is your function which calculates the linear answer, and then I will just basically what I'm doing is func of v I'm calling for my input. Like I just take the input of the vector. If n is 1, then cout 0. I just handled it right here. Then I have this ans variable in which I'll store the minimum. So ans equals to func of v. So this is the first check, like before rotating it. Then I rotated once. Like I just push back the first element and erase the first element. So basically I left shifted the array, and then again I called the func of v and took the minimum. And then again I shifted it once more. So v dot pushback v of 0, v dot erase, v dot begin. And then again I took the I called the func and took the minimum. And finally I just printed the minimum answer out of these 3. So I just did this computation 3 times, right? So it is often. Okay. So this should be clear, guys. And this was the solution to today's div 2D, and that's what we will discuss today. And I hope you guys understood all the solutions, and if you did not, then no problem, just make a comment on the YouTube video and I will reply to that doubt. Or you can, or if I don't reply to that comment on YouTube, you can ask me on Codeforces also. I will reply to that. Like just DM me on Codeforces. Okay. All right. So I'll take your leave now, and thanks for watching. All the best. Bye bye.